this to me is one of the best parts of our event, and that is having customer testimonials. Last year was really cool to have a couple of different applications that were doing some different things. We had different presentations as well. And we learn an awful lot when somebody applies it outside of the trihedral building, if you will. And so we have 3 of them today. We're going to begin with Dave Ubert to come talk about the long-term planning parts. So he's out of the consulting engineering world. In fact, for 27 years, he's been in this business doing water, wastewater, pulp and paper, some food and beverage. But in all of those cases, looking for secure SCADA, secure controls, secure communications. And today he leads a team at CDM Smith Consultants as a senior automation. So really covers the whole country with those folks that help him out. He's actually based in Orlando, Florida. We're glad to have Dave Ubert. Dave, come on up here, and everybody give it up for Dave! Woohoo!
Wow, well, that was worth it. Thank you, Alan. Thank you to the VTScada guys for inviting me here. I was here last year just as a participant, had a great time, so I pleaded and begged to come back, and so here I am now doing the presentation, and I hope you enjoy it. We're going to talk about long-term SCADA planning. I like to kind of let this topic be analogous to maybe building your home or fixing up your home. It's kind of how I look at long-term planning of any kind, because it's the biggest thing we own. Certainly SCADA systems are expensive, and they're difficult to maintain. There's a lot of technology. It costs a lot of money, and so we want to make the right decisions, very similar to how we do our home. So that's my analogy that I'll be using today. So when you do any kind of long-term planning, the best thing that you can do to start with is you begin with the end in mind. A lot of us have heard that buzzword, that phrase before, begin with the end in mind, and it's a great way to begin your process of implementing a long-term SCADA project. So the best thing that happens in this context is it gives you an opportunity to improve your overall system. And that's my favorite part of long-term SCADA planning. I get to do a lot of the master planning for municipalities, mostly in the water wastewater sector, but also with some other industrial clients. And long-term planning is a lot of fun if you do it right. So what you do is you look at your opportunities in the front end, and you start to dream a little bit about where you're really going to go with this thing, or even beyond where you think you want to go, and start getting your mind and your what I like to say is bring a bunch of smart people in a room and let the brain cells start firing. So you get real innovative at this stage of the process at the very beginning. You get very innovative and you look at all of your opportunities that are out there. You involve others, like I said, you get all the smart people in the room and you start to brainstorm. And that bringing other people in the room is extremely important when you're doing any kind of long-term planning project, because you kind of, I'm surprised at the type of people that we bring in the room, operators and IT folks. We get management folks in there and maintenance people, and everybody has a voice, and they feel like they have a little skin in the game. So it begins, this long-term planning process really pulls everybody in, and it gives everybody some skin in the game, and people like to be part of something big. So it's a good way to start out. Consider current technology. That's one of the biggest ones that we do in this room as engineers and technical people. We want to look at the latest technology that's out there, and this is going to be obviously the focus of this talk. We're going to be looking at different technology and how we go through that process. You kind of consider things if money were not an issue. Even when you're doing a home project, if money were not an issue, what would I do? It's not that you can do those things, but you have to be able to dream a little bit in order to reach a nice end game, and you can work with the money later as you come up with some ideas. There's different ways to facilitate projects, right? So that's why I put that little piece in there. There is a reality to determining the long-term SCADA. There is a reality to the big kitchen that my wife wants and the small kitchen that I want, because money is still a factor in all of these things. And ultimately, we want to define our goals for a successful SCADA project. So that's the end game, a successful SCADA project. So what is successful SCADA? What does that mean? Well, it can mean different things to different people. but we definitely want to land on that question and decide for ourselves, whatever your project is, whatever your industry is, if that project is successful, what does that look like at the end? So that's kind of that beginning with the end in mind thing. So we want this SCADA system or this project, we want this thing to perform tasks that it was designed to do. That's successful to me. Does it do them efficiently? So these are things that we definitely want to incorporate for long-term SCADA projects. And again, I throw that word innovative up there. I know it's a buzzword in today's society, but it's really critical when you're doing long-term planning, because if you're not using an innovative approach, by the time you get to the end, you're going to do it all over again, and that's not really where we want to go with this necessarily. We want to maintain it and keep it moving forward. Again, we want to keep that staff engaged, but we also want them to be trained well, and so that has to be part of that long-term planning process. So as an engineer, I usually step back and I look at the people that I'm dealing with that are going to be responsible for the project at the end of the project and make sure that those folks are trained up. And typically, my response that I get from these folks is they get excited about the project because they're going to get trained up on the project. When I was very young, kind of starting out my systems integration career, I was developing a small system and put it all in and got PLCs going and my HMI was going and I got to training and there was a guy standing in the back and he was kind of had his hands folded and he had kind of a scowl on his face, and this is kind of my first go at training, and I was a little uncomfortable, and I finally asked him, I said, what's the problem here? I mean, you've got to know this stuff and I've got to train you. That's what I'm being paid to do. And his response was, I've got 2 years left and I don't want any problems. And I don't want to be involved in this project and I don't want anything to do with this stuff. And it was really kind of sad because in my perspective I said, well, what you really need to do is you really need to be trained and you need to be more engaged in this process because you get actually to benefit from this whole process as well. So part of the long-term planning really depends a lot on who's going to end up, who I'm going to hand the keys over to when this project is done. So they have to be trained. So training to me is a huge thing when I'm doing any kind of planning like this. We want to make sure systems are maintainable, reliable, and supportable. And I put et cetera because the et cetera, there's a lot more bulls that go along with this. But we want all of our systems to continue to operate, to be sustainable, so easy to work with, maintainable. People can work on them. People are trained properly. And that support, if training was number one, support to me is number two because the products that you use up in the front end have got to be supported a year later, 2 years later, 10 years later, and 20 years later. So a typical system that, in my mind, a SCADA system of any kind needs to last at least 20 years with the technology and then can be upgraded and maintained through that whole process and continuing on from there. And finally, maintenance plans are in place and budgets are established. So obviously there's the money piece, getting the money in order and getting the products and the equipment in your mind so that they're all maintainable. So where do we start? Typically, a great place to start is master planning. And lately, over the last couple of years, I have a lot more clients that want to do master planning, which is great because if you fail to plan, you are actually planning to fail. And back when I had my own system integration firm, that was our motto. So failing to plan is planning to fail. So we would have planning sessions all the time to make sure that as a company, we were growing and we were training our people and we had goals and we had all sorts of things. So you've got to plan out the process. And the price tag on a SCADA system, surprisingly enough, when you build a plant, so in our engineering world, we might build a new facility. Right now we're working on the big Houston project. It's a $1.8 billion water plant in Houston, Texas. We're joint ventured with another engineering firm. And this planning stage up in the front end is so critical. But this $1.8 billion price tag is a huge amount of money to me, to anybody, I think. I don't know, is there anybody in here that has $1.8 billion on you? So because the stakes are so high, you start to look at it and you say, well, in all of this $1.8 billion, and we're building structures and tanks and pumps and big VFDs and MCCs, all this stuff is going in that, so the price tag goes up. But in all this, the SCADA system is not actually a lot of money compared to all the rest of what's going on. And the SCADA system runs your entire plant. So in all reality, we have a great opportunity to spend our money wisely in a product that really helps the plant and gets things running along. So planning up in front, you want to, the time spent up front obviously is money well spent. And again, that analogous to the improving your home, making home improvements, you can spend some time up front so that you spend your money very wisely. So the master planning actually provides a roadmap for your CIPs. We do that all the time where we help clients mostly get up to the end of the year so that they have an Excel spreadsheet with all the weighted averages and it makes an analysis of what you're doing in your system, what you got going on in your system so you know what to replace. So it gives you a little bit of a roadmap for your capital improvement plans. And then, of course, where do you start? You start with your budget. There's the money part. That's obviously a major part of what you're doing because most facilities, industries, we're all limited by the amount of money. So we identify potential budget sources. Maybe there's some federal funding, state funding, local funding. Yearly budgeting. Identify reoccurring and one-time costs so that you have to do some yearly budgeting. And we do a lot of that analysis with software products and hardware products as they have reoccurring budgets. And also you need to begin doing an evaluation. The long-term SCADA solution starts as you evaluate your equipment that you have now. Sometimes you have existing plant and you have to do an upgrade or something along those lines, or you have a brand new plant and you are starting from scratch. Wherever you're starting, you need to evaluate what you've got. So if you have a new plant, it's pretty easy. You don't have much. So upgrades, though, you have a lot of issues with obsolescence, identifying issues, and prioritizing, creating that grading that I talked about. So the grading system, this is one we used in city of Sanford, I think. And we just created a weighted average for prioritizing equipment that had problems. So we had a number of different things that we looked at. As I looked at a piece of equipment, say a VFD, how old is it? How critical is it? How does the equipment look on the outside? Is it deteriorating? And you start looking at, we had all these different columns for the different pieces of equipment, and that would give me, at the end of it, a weighted number that I could look at and determine, do I want to do this first, that second, that third, and that kind of thing. So it helps me do a little bit of planning down the road. So next, we got to identify options. Instrumentation, that's a great place to start. So you start all the way in the field. The previous session that I was in on the dashboards talked about pulling in data. You have to have instrumentation. If you don't have instrumentation, you can't measure something, and if you can't measure something, you can't control it. So instrumentation is extremely important. If you have existing instruments, you have to do that evaluation. You can't get away from it, you can't get around it. You want to replace it with new technologies. So now you have to look at the new technologies that are available, and this is where you need people like engineers or contractors that know what they're looking at and know what the new technologies are out there, so that gives you options. As an owner, would give you options. A lot of the new instrumentation is going to communications, so there's a lot of Wi-Fi, there's Profibus, there's DF1, there's all these different protocols floating around, Field Bus, and a lot of the instrumentation is supporting that or not supporting that. Where do I want to go as an owner or as a person that's determining where my long-term planning is going to go? So do I want to get into communication devices in the field? Do I want to have to deal with the complexity? That's one of the big things that I talk about a lot, is creating a system that's not too complex where people can't figure out what's going on. So you have to know the people that are going to hold the keys when we walk away and have to run the system. Those people that run the system have to have a system that they can maintain. So if it's too complicated for them, it's not a good system, it's not a good solution. Controllers are another thing that get incorporated into long-term SCADA planning. You want controllers that are easy to install and maintain. There's a lot of different options. They have to be supported by the manufacturer, and I look at vendors that are in the area. So when I look at supporting a client, say for instance the big Houston project that I'm working on, if I'm looking at instruments, or I'm looking at HMIs or controllers or whatever I'm looking at, VFDs. I want to know if that product has had good support historically and where those products are going in the future. And the future part is the hard part, so I look at the history part all the time. Have you gotten good support from this vendor? Have you got good support from this manufacturer, whatever it is? And so that's another key item that I look at very carefully. The front end part, that's the HMI part, the part that the operators look at. You got to spend time on this option. It's one of the biggest things, of course, VTScada. That's the product that we all know and love today. Everybody's working on it. It's a great product. And you have to spend time looking at the software. It's the operator interface to the entire system. So is the HMI important? Of course, the HMI is extremely important because operations and maintenance and management have to look at their system through this piece of software. So it's absolutely critical. There's a lot of options. Make sure your vision is captured. So one of the things we talk about bringing everybody in, you want to bring operations staff in. This is going to be a key part for them to be able to look at and kick the tires on this HMI, this front-end device. Here we go back to that support. Support, manufacturer, contractor, in the industry. So I look at the support. Houston, in the big Houston project, we selected VTScada. So it's a very nice project that we have for VTScada, and I'm pretty excited to get this thing running. But in order to make that decision, had to look at their support and their support arm and how they've treated us in the past and all of those things. And I grade all the different software manufacturers on these type of metrics in order to make decisions about the products that I'm using. Are they supported in the area? Do contractors, systems integrators, are they around the area? Do they support the product? So these are the things that I look at to make sure that I'm picking the right software and hardware platforms for a client. So now we look at migration strategies. Obviously, there's different ways to approach things. In my world, this is one of the most important things I do once I finish all of my design. Now I've got to figure out, well, we've got this great design now, great plant. How are we going to implement this for real? And I have to put my construction hat on, and I have to start thinking about how this thing is going to move forward. So obviously, if you have one large project like the Houston project, that's an easy one for the most part because it's a new build-out. But there's a complexity to it because they have an existing plant. And that has to stay running for 5 years while we transition over to the new plant. So you can imagine the type of problems that that will occur during the construction phase of this project. So you have to take the time budgeting and planning, even with a large project, a one-and-done project, which is not this project. It's a multi-phase project. So most projects are phased projects because we have existing facilities out there. And that's just the way most of the projects that we do actually run. There's some new ones, and those are fun, but a lot of them are just, you have to come up with some phased approach to implementing and migrating all of this equipment, software, and hardware while you keep everything working. And of course, probably everybody in this room has heard that a million times. You need to keep this system working while you implement this new thing. So we have to come up with this migration strategy and really think through that. All of the what-if scenarios, so you got to take time budgeting that. And I said you'd make more time planning that because bad things can happen. Create a logical approach based on your evaluation. So you go back to that evaluation. So now I start looking at what's my most critical pieces that have to be dealt with first. I had one client where we had we were going to upgrade their entire water plant, every PLC in the water plant. We were going to upgrade to a new processor platform, a new controller, and we were going to upgrade their HMI software. And so as I was walking through just the first time, just doing a site walk, I saw a panel that was a panel for their, it was a pressure filter. So they had a single pressure filter and the panel outside, and there was no redundancy to that process. And the panel was kind of cocked open as water was running on the inside of the panel. And so we opened the panel, and I couldn't even believe it was even working. And so I said, well, I don't have to do much evaluation here. You better do something with this thing immediately. And I don't even want to touch it. So this is a non-redundant pressure filter that their entire water plant, if this thing goes down, they're out of water. So that became obviously the most critical piece. So you have to walk around, you got to do your evaluation, and you have to prioritize what you want to work on first. How long can systems be down and unavailable? Obviously, if you're replacing MCC equipment, you got to unplug the power, get your MCC equipment, replug the power, and you're going. So a lot of this stuff has to do with redundancy, redundant processes, but you have to look at these things before you get your hands dirty in construction. And finally, identifying system incompatibility. So if I bring in new products, are they going to be compatible with the equipment that things are running on? And that's something that we run into often now because everything seems to be networked, it's communicating, it runs this protocol, that protocol, and it gets very messy quickly, so we got to make sure things are compatible, software and hardware. When you look at controllers and you want to migrate, and we're looking at these migration strategies for hardware like controllers, testing the code before installation, this saves money in the end. So you're going to spend money, but you're going to save a lot of money in the end. And there are so many examples that I have in my mind of lessons learned, which I think Mike will talk about later, but lessons learned, how you saw things go really bad because you didn't do what you were supposed to do in the front end. So this over here is a facility in Tecate, Mexico, where they build MCCs. And what we did is we did all the witness factory testing for all these MCCs. I can't remember how many we had. We had a lot of MCCs. They were all smart MCCs, and they were all networked. And so we had the integrator go there. I went there. The owner went there. And we tested these MCCs for, I think it was 2 weeks or something like that. And we tested every single one. We tested everything on that line. And when we did the installation, that 2 weeks that we spent was money well saved. We didn't have one problem when we transitioned over from their old MCC stuff, non-smart stuff, to the new smart MCCs. It went in almost flawlessly. We had one problem, whereas they were delivering one of the MCCs, they dropped it 50 feet and it broke. So that wasn't my fault, and I was not near it. I guess safety should be part of this too. Huh? Review special requirements for switchover. So sometimes there are spatial requirements. So you have to make sure there's space for setting other things up, things like that. On the HMI side, so now we're looking at software. Typically, we have two systems running side by side, requires space. And a lot of this kind of thing floats off the radar because it's such a simple thing that you just miss it. But we have to have space. And I put in there again, operators have to be trained ahead of time. The last thing you want to do is take a brand new SCADA system with a screen and set it in front of an operator who's never seen it before in his life, and the fear of God will appear on his face, and that's not a good start for your construction project. Training people up ahead. I keep mentioning training, but in my world, it helps me out so much. When I was a system integrator, I realized very quickly, if I train my clients really well, they only paid me for a week, I'll give them 2, because they won't call me as much as they would if I didn't give them training. So that is my philosophy in training. Financial considerations, you don't want to turn out like this guy. You have to do the dreaded B word for budgets. You definitely don't want to get caught short, and it happens often because stuff costs money, and sometimes it costs more money than people think. So we do a lot of construction estimates to make sure that clients have enough money to get to the end of the project. So costs to consider. You have initial engineering costs, all that design time. All that time spent up in the front is going to save you time in the back end if you do it correctly. Spend your money and time wisely. Calculate costs over time. So 5, 10, 20 years, you do an analysis and you run out that analysis. And when I'm looking at different products, that's what I use. I use 20 years max. So if I'm looking at an HMI, for example, I'm looking at what's the cost over 20 years. Because there's annual costs, there's reoccurring costs, there's upgrade costs, and we run calculations and we come up with an end number. And I do the same thing, again, with my analogy of the home. If I'm buying products, I want to know, how I have to maintain my, say, a refrigerator's got filters and it has lights, and you want to just run out those calculations as an example. Annual support contracts, maintenance and support contracts, that's more for contractors. So if a municipality or some industry has a SCADA system, they should have a maintenance and support contract, so if they need help, they can get help very quickly because they already have a contract for a year. And they just call them up and people are ready to go. So you want to have those things in place, and you want to know how much they cost and what you're getting for those costs. And of course, during 20 years, you're going to have to replace parts, and you want to calculate that as well. Sustainable technologies, that's just by and large what we're trying to accomplish. We're trying to install better solutions, better equipment, better methodologies, so we have better products at the end of the day. So you want to use sustainable technologies, and that's in that dream stage. Where do we want to go with this system? So looking at sustainable technologies is a great way to improve your system overall. Should save you time, should save you money in the long term because you're using products that are sustainable. Improves the overall system performance. This is something where we want to leverage efficiencies. That's something that really is should be part of anything that you're doing. Again, I'll use my home analogy. I'm trying to buy an air conditioning unit today. It's got to be much more efficient than the last one. And I want it not just efficient, I want it really efficient so I don't have to deal with this and I can save some money. And so we can run out our costs and see how much money we can save. And I guess it's 1 year payback is what the reinvestment time was in the previous. So instrumentation, that's critical to the success and longevity of SCADA system. So you want to use instruments that are going to give you data so that you can control your system how you want it. In that planning stage, that's what you're looking at to make sure you get all of your instruments in place. So it's really critical to say, what do I want to do with this system? And sometimes I will, as a design engineer, when I put my design hat on, I will over-design a little bit in an area where I'm unsure just to make sure that I'm at least getting the data that I'm going to need in order to do the control that I want to do, and then some. So sometimes that takes some more instrumentation, and it takes some more thought process, but I run through these calculations in my mind to see what's a good solution. And then bringing this information into the control system for the operators to utilize. Ultimately, that's our end game with long-term SCADA planning. Security, you have to mention security. I'm actually tired of doing cybersecurity talks, so I didn't even want to mention this, but you have to mention it. You've got a budget for this. This is something that's going on these days that you cannot get away with. I go to these cyber security conferences, and everybody's throwing up. They're still throwing out their Stuxnet and all of the big scary security breaches that we've had in the past. But it's a reality, and you have to budget for security. Cybersecurity is a very real thing, and security, it's not a destination. It's kind of like your health. We all want to be healthy, so we want to lose 10 pounds. But health is not a destination, it's a journey. So you got to keep working at it. Security is the same way. The bad guys it seems they're so active, it's hard to keep up with them all. But they're out there, and we have to stay one step ahead all the time. So security is a big deal, and you have to put money in your system for security. Utilize tried and true equipment. When you go to vendors, hardware vendors, software vendors, make sure these vendors are engaged in protecting their software. They have patches coming out on a regular basis. Patch Tuesdays, they're plugged into all of that. I put implement RMF type cyber. That's just the risk management framework is something the DoD uses a lot. It's a great framework to develop a plan for security. And basically they start out with an evaluation of your criteria, and they run this whole thing, and you get a lot of good paperwork, but you've got somebody watching the security door so that these things are kept up to date. So you have to have these strategies in place. ICS CERT is a great example of on the web. You can get good security information from them, ongoing updated security, and that's how you find out about some of the different software breaches that we've had in the past. Those guys keep up with it all, so they're great to stay connected with. And of course, at the end, you're done with all your stuff. What could possibly go wrong? You have to budget for the unexpected. So things will go wrong. I've been doing this a long time, and I'll do a simple little pump station, and I'll design it, throw a paper together, and I'll give it to somebody, and every single time they'll come back with some red marks on it. So we're just not perfect. We're in a hurry. We're doing stuff. You got to budget for the unexpected because things do happen. So you have that contingency money. You have to have some sort of contingency planning in part of that process. So as a wrap-up, again, training staff. You hear me say that over and over, but as part of that long-term, you've got to train staff. You've got to bring staff in. So if you have attrition going on, people are retiring, you've got to account for all of that stuff. Select the right hardware. What's the lifespan projection of that hardware? And that's why I say historically, you got to look at how that has performed over time because you don't want to get into some product that's going to go away in 5 years. You got to select the right software. VTScada, right? That's the right software today, specifically for your system. So you take a hard look at those things. And finally, the big one, you include everybody in the selection process so they have skin in the game. And that's all I've got. Thanks for your attention. Questions?